Afternoon. From Parul University, we have organized today a webinar on leaching mass transfer operation. For this, we have an expert, Mr. Parth Shah, Assistant Professor from BPTI College, Bhavnagar. So, on behalf of PITDS, we welcome you, sir.
Thank you, ma'am.
Hello.
Yeah, thank you, ma'am.
Yeah. Okay, sir. We can go ahead. Yeah.
Yes. So, good afternoon, all.
Okay, fine.
First, I would like to thank the chemical department and the Parul University Department College for inviting me to share my views and knowledge on leaching mass transfer operation. I would also like to thank Professor Nitesh to for contacting me and approach me for this presentation. So, without wasting much time, let's start with the leaching as mass transfer operation. Now, basically, in today's presentation, I'm going to give brief introduction about the leaching, then preparation of the solid, why it is important, then the types of leaching operation, then leaching equipments and material balance if time permits. Fine. So, first of all, why leaching or what is leaching? So, when we are separating liquid from liquid mixture, it is known as extraction. But what if we have to separate solid? Now, separation of solid is not an easy task. As some of you know, the mixing of solid, it is very difficult to separate because it has almost similar size, shape, and we cannot identify if it is also immiscible, right? Like if we have mixture of sand and salt. Now salt is white color and sand has another color. But still, if you want to separate out, it is difficult to separate by just using your hands. So we have to use some technique so that we can easily take out that material. So here comes the leaching operation. So in general, if I want to say that it is the separation process of particular component from the mixture of two or more solid component by extracting into a particular liquid known as solvent, right? So there are two mixtures, there are two components. One has to be extracted. See, salt sand is very simple example, but if industrial example I have to give, like gold mines, if I have to extract gold from the mixture of gold and sand, now it is very difficult by doing it uh, simple screening. So we have to increase the operation, the rate of operation, and the purity of the gold. So that's why what we are doing, we select one solvent. That solvent, what it will going to do, it will going to simply make the solute soluble in that solvent. Like in our case, gold. Now gold is soluble in cyanide solution. So we can take gold in cyanide and then separate the cyanide from the gold solution. So we can recover the gold. It is very simple process. We first mix solvent and solute and then extract the solute from the solvent. Right? So two things happening right now. One is solute is mixed with the solvent. Another is solute is recovered from the solvent. So first we are understanding how it will going to affect or how it is useful if you use solvent. Now these are the some of the examples. Like gold, as I said, that gold ores using sodium cyanide solution. Second is sugar. Now sugar beet, we all know sugar beet, right? Sugar beet, if we have to extract sugar from that, then what to do? Then we simply add this sugar beet into hot water and we extract that sugar. So this basically gives us the opportunity to extract the sugar and leaves the waste material aside. So that way we can get the sugar in hot water. Again, understand this, that solute is miscible with the solvent. So solute is dissolved inside this solvent and our solute is solid. Our solute is solid. Another is copper mineral. So we can use the sulfuric acid into copper mixture, right? So this way we can extract industrial material using the liquid solvent. So these are the example of leaching, right? So by far we can understand what is leaching and where it will utilize in industrial scale. Now, the most important part or any mass transfer part, it is the solid. What is the surface area of the solid? Because it is basically diffusion. The solute is dissolved inside the solvent and solid is the solute dissolved inside the solvent and it is recovered. So for that dissolution, the cross section area is very important. Once the cross section area is achieved, then we can have the maximum extraction or maximum leaching of this solid. So for that, number one point is preparation of this solid. So for the effective leaching operation, we must have the good preparation for the mixture. Here, the solid mixture is considered as a mixture and we have to extract it. Now, for that, what happens sometimes? That solid is surrounded by the insoluble solid. Our solute solid is surrounded by the insoluble solids. Now, it is very difficult. If insoluble solid are completely surround the solute, then solute will not going to dissolve inside the solvent. So we have to take precautions and make arrangement such a way that the solute must contacted with the solvent. Then the leaching operation will be performed. So preparation of solid is very important, right? Also, the crushing and grinding. What happens if one solid is surrounded by the number of insoluble solids? So we crush that solid. We crush it, we grind it, and then we leach out. So this is very important. Crushing and grinding. Then only effectively we can leach out the solute. Now again, crushing and grinding is not easy. We know in laboratory, if we have to crush grind like 2-3 kilograms, it is very easy. But when I am saying gold mines, right? Gold mines. Now gold mines are tons of mixture, like 10 tons, 20 tons. And from 20 tons, we are getting like 500 gram or 600 gram of gold. So it is not easy to crush and grind entire thing because it is costly. Crushing and grinding both require electric utility input. So if we are having a copper mineral, then what we are doing, we crush to 6 mm particle size and then leach it out for 4 to 8 hours. Barabar je? If copper minerals are 6 mm size, it completely leached out in 4 to 8 hours. But if we keep size of 150 mm, like 15 centimeter size, so 15 centimeter size, we need to put it for 4 to 5 days to completely leach out that copper. So the scale you can see from 150 to 6 mm. If we can reduce that much particle size, we can increase the speed of the operation drastically from 4 to 5 days to 4 to 8 hours, right? So that's why preparation of solid is very important. right? So 150 mm to 6 mm particle. The solid preparation or solid leaching is very, very effective if the particle size is reduced, right? But the grinding cost, we have to consider the grinding cost. If we have doing for gold ores, it is okay because gold is very precious metal, very costly metal. So if we can get maximum gold, it will be useful. It will be price worthy. But there is a high chance the second material like copper. If we have to extract copper, now copper is not that much costly as gold. And if we are doing same grinding operations such as gold, then it will be very much costlier for us. This will allows us the flow level. The flow of the particle or the solvent. So when viscosity decreases, diffusivity increases, and both is favorable condition for the leaching, right? So leaching is favorable at the high temperature. Again, what I'm saying is leaching we can get till the maximum allowable temperature from the solvent or metal is not deteriorating. Metal can withstand high temperature, but the solid inside that the solvent we have to restrict to the below boiling point. Okay. With increase in the process temperature, the natural product sometimes degrading in the process at high temperature like sugar beet. Right? If we can go up to 90-95 degrees Celsius, then there is chance that sugar beet can degrade. Right? So that is the two parameters, the size of the solute and temperature. Now, there are basically four types of metal leaching industry that uses four type of operation: dump leaching, heap leaching, tank leaching, and in situ leaching. I will not going to discuss all four, but I am going to discuss one of two in the my presentation. Now these are the metal extracting leaching operations. Like first of all, in situ leaching. What is in situ leaching? So in situ leaching means in place leaching. In situ leaching means in place leaching. When solid or the high volume of the solute surrounded by the material like gold mines, we cannot get the entire mine to the industry. Then we have to do the in place leaching. The place where mine is available, we have to do leaching over there only. This is known as in situ leaching, or we can say in place leaching. Again, it's an unsteady state operation. Why unsteady state? Because the concentration of solute is changing over the entire range of the uh, solid distribution. So sometimes there is high rate of diffusion, sometimes there is low rate of diffusion. So it is an unsteady state operation. It is the leaching that takes place at the mine. The process is done by circulation of solvent over the ores. Ores means the basic uh, metal or the mixture that is available in the raw form at the mine. From that ore, we can get the material like aluminium, bauxite, right? So gold ores. From that gold ore, we can get the gold. So we recirculating or circulating the solvents and get the gold leached out, right? With the circulation over the mine, the soluble material get dissolved in the solvent and that leach solution is collected separately, which gives separation from the mixture of ore in mines, right? So last point represents when there is a solvent is contacted with the solute, it get dissolved and then we can collect it separately. So we have eliminated the entire waste material or other materials which are not useful for us. For copper leaching, we are only focusing on copper. We are not interested in the other metals, right? So that's why we are only focusing on the particular target that this material needs to be extracted, and that leaching is performed. So from the high volume, we reducing to the solute plus solvent, that is that our solution. For example, removal of the salt from the earth surface is done by this process, that is in situ. We are not taking the salt. Or the separation of the uranium from the mining. Right? Now uranium, the ore is oxidized in the place to solubilize in carbonate solution. So there the in-place leaching is done. Right. So this is the one kind of example. Now other thing is heap leaching. The name itself suggests the heap which generate the heap of the low grade matter. Right? For low grade matter, the crushing and grinding is very expensive. Right? So heap leaching process is performed. Low grade metal like copper. Right? So the material is collected from the mine and in particular place a huge lump is formed. The heap like lump is formed over the entire surface. And that lump, the solvent is poured from the top and the solvent is supplied and leach liquor is collected to the bottom, to the drain pipe. Right? So the heap of material is formed and then the solvent is poured from the top. So this way we can separate the solute like copper from the pyrite ore. So 6 to 8 meter tall and 120-meter wide. So this much big heap is built, solvent is pumped through the pipeline for the leaching, and drain pipe collect the leach solution to take out the process. Right? So these are the two major types of the uh, hello. Am I audible? Nitesh sir? Okay. Uh, I guess I am audible. So I continue. Anyone here from coordinators? Hello? Okay. So the heap leaching, in heap leaching, as I have said, very low grade matter, the crushing and grinding are very expensive. So what we are doing, we simply so what we are doing, we collect that low grade low grade matter or the material that is extracted from the earth. We make one big heap over the wide range of the land, and that material is contacted with the solvent. So the copper is separated from the pyrites like this much big ore, like 6 to 8 meter tall, 120-meter wide, and 800-meter long. Now that entire heap is contacted with the solvent which is pumped, and drain pipe collect the leach solution. Right? So this way leaching is helpful. The another important system that has been studied for the very effective leaching operation is the shank system. Of course, this is very important topic for university syllabus curriculum as well. Now there are six number of tanks. All six number of tanks are arranged like this, right? And it is a counter current leaching operation. It is a counter current leaching operation. So what happens in counter current leaching operation? The solvent becomes strongest in terms of solute as compared to cross current operation. Counter current is high efficiency than the cross current operation, right? So instead of moving the solid, the liquid is transferred. So very first top point to be understood is that all six tanks, solid will remain there only. Only liquid is passed out from one tank to second tank to third tank, and so on. Right? We studied that detail in detail. But you have to understand there are two things: solid material and liquid material. Now, solid material is not moving anywhere. Solid is stayed inside that tank only. But liquid is collected in one tank, perform the leaching, and then transferred to the second number tank. Right? So there are six tanks used for the operation. Now, as per figure A, consider that tank number 6 is empty and 1 to 5 is filled with the solid. The tank 5, just before 6, is recently filled with the solid. Okay, so there are high number of solute available in fresh solid, right? Because it is not extracted before. The leaching has not been performed just before. So what happens? The tank 1, at that point when the tank 6 is empty, the tank 1 has the longest time of solid because there are fresh solid is added in tank 5. So tank 1 is the highest leaching operation performed, right? And it has most concentrated solid is added in the tank 5, right? So fresh solid is contacted with the fifth time solvent, the mixture that comes from the first to 2, 2 to 3, 3 to 4, 4 to 5. So already the liquid has performed 4 times extra leaching, and we are adding to the fresh solid. So that's why it is known as counter current operation, right? Why counter current? Because fresh solid is contacted with the maximum solvent that has been used, right? So this fresh solvent is added to the tank number 1 and the concentrated solution is extracted from the tank number 5. So that is the reason why this is called counter current operation. When this done, the concentrated solvent is taken out from the tank 5 because in tank 5 fresh solid is added, concentrated liquid is added. This concentrated liquid becomes more concentrated because there is a fresh solvent, fresh solid. I'm sorry. So that fresh solid take out can give maximum amount of solute, and that liquid is separated. So you can see in figure number A. In figure A, the concentrated solution is taken out from the tank 5. And fresh solid is and a fresh liquid is added to tank number 1. Correct? Now, what happens? We take out that liquid from the tank number 5 and then we can move that tank number 4 liquid to 5, 3 to 4, 2 to 1, 1 to 2. So now the cycle becomes as per figure number B. As figure B. So now the fresh solid which was added in tank number 6, which was just emptied, the solid is taken out from the tank number 1 because it was leached out for 5 times. Now the solid is taken out. It is known as spent solid, right? So after 5 times, the fresh solid is added into tank number 6. Again, in next turn, what happens? In next turn, what happens? The spent solid is taken out from the tank number 1 and liquid is transferred from 5 to 6, 4 to 5, 3 to 4, 2 to 3. So now remember what happens to tank 5. In tank 5, previously we have added fresh solid. So it was leached out first time. Now liquid is transferred from 4 to 5. So again it was leached out. So it is a second number of time. This way 5 times the liquid is contacted with the same solid which has low amount of the solute. Clear? So this way the counter current operation and continuously solid is taken out, fresh solvent is added and concentrated solution is taken out. So this way we can get the maximum amount of leaching. So this Shank system is very important, right? If you have any doubt, you can write or coordinator will convey to me. Okay. So this is the Shank system. This system is very useful in industry. Now, there is equipment, leaching equipment. There are basically four major equipments that industry are using for the leaching, right? Apart from the Shank system, like Kennedy extractor, continuous countercurrent decanter, rotocell, Ballman extractor, these all types of equipments were used, are used in the industry. So we go in a not detail but in a brief. So how the Kennedy extractor works. So this is the figure of Kennedy extractor. Same way the solvent is flowing from this side, from right side to left side. Right. And solid is traveling from the left side to right side. And from the drag chain, from the drag chain conveyor, the solid is taken out. Right. So this is the extraction performed with the Kennedy extractor. Right. So what happens in Kennedy extractor? The solid is traveling from the first fins from to the second fins. Right? So this type of solid flowing is performed in the Kennedy extractor. Right? And the solid is the spent solid is taken in the discharge. The spent solid is taken in the discharge and the fresh solvent is added there. So this is also a counter current operation. This is also a counter current operation. So what happens in Kennedy extractor? The leaching is done in the stage-wise operation. The solid is pushed in the tubes by movement of pedals and the solvent is flows in counter current operation. So perforation of solid between stages from pedal is possible. So number of cascade tubes are connected in the series. So these are the cascade of the tubes. This is the cascade of the tubes, right? And this can be traveled. The second operation is continuous countercurrent decanter. Continuous countercurrent decantation. What happens in decantation? If you see, the leaching solvent is added from the right side. From tank number 4, right? The solid is added in the tank number 1. The solid is added in the tank number 1. So again, it is a counter current operation from where the sludge is traveling from the underflow and it will fed to the tank number 2. The sludge means solid. So that solid is traveling to the tank number 2. While the solvent is added from the tank 2 to 1. So from tank 2 to 1, and the solvent is traveling using overflow. And in underflow, the sludge is traveling. Again, from tank 2 to 3, the sludge is traveling from the bottom and solvent is traveling using overflow. Right? So this way, in countercurrent manner, continuous countercurrent decantation is work. It is also very high efficiency equipment. Right? But you can see there is pumping cost, there is equipment cost. So we have to optimize which equipment we need to use in which type of experiment. Right? So the overflow is for solvent or solution of solvent and solute. And the underflow is for sludge. So this is the same thing that has been written. So in phosphoric acid or phosphate rock with sulfuric acid. For the phosphoric acid, we can use continuous countercurrent decantation. Right? The another thing is the rotocell. Now, I'm not going into detail because the time is not permit me. But you can see the figure. It is a similar kind of arrangement, but with the rotation of the compartments. So there is a little difference than the continuous countercurrent decantation, where there is a four different reactors were there. But this is rotocell. There is entire compartment is prepared and that compartment is rotating. So that way the solvent is leached out and spent solid is taken out. Right. So this way rotocell. Another experiment equipment is the Ballman extractor. Now this also useful in the number of industries. Now what happens in the Ballman extractor? The solid is inletted from the top of the equipment. Right? And it will travel from the entire section from the right side, then it will go to the bottom and then it will come out as the top. Now if you see a light green color shadow is represented over there. So it is a spent solid. What happens to the spent solid? That the solid is leached out maximum. There is further no more scope of the leaching. So that solid has to be taken out. So there is a screw conveyor at the top which collect the spent solid and it get discharged from the top. Again it becomes empty at the top and when it moves to right side it will again fill out with the solid. So this way we can move solid. Now another thing we need to understand is solvent. How solvent is moved? So liquid is pumped out from the bottom and it will added to the from the top. So solid is added. After solid addition, there is a liquid. And liquid will flow in the downward direction. So from one side, used solvent is added. From the other side, right? So one side is fresh solvent, right? Where the leach percent extracted solvent, which has some amount of solute in it. That with the fresh solid. Counter current extraction, leaching. So this type of extractor widely used for the extraction of vegetable oils from the seeds, right? Consists a number of baskets. See that segment is called basket, fixed onto an endless chain having descending and ascending leg. One side is going downward, one side is going upward, enclosed in vapor-tight chamber. Each basket has a perforated bottom. Perforated means the liquid can travel from that basket to the another basket. And at the end, it will collect it at the bottom. Right? Then, see if you observe minutely the descending leg, that is the right side one, which has 50% extract. It collects as a full extract and it is separated as a out product. From another side, there is fresh solvent is added. Now that fresh solvent is collected as the 50% extract and it is recirculated. It is recirculated, right? So from one side, it will go to downward and that fresh is again recirculated from right side. So this is also again a counter current operation. This is also a counter current operation, but not exactly the type of decantation type, right? But this is also known as in counter current, right? The solid fed through the hopper into the basket at the top of the descending leg and partially enrich the extract is sprayed on the solid, right? Just I have explained that. So that way the solid is collected. The liquid is percolated through the slowly moving basket and collect at the end of one bottom sum of the unit. The fresh extractant is sprayed on the top basket in the ascending leg and percolate through the rising basket and collect in the another sum at the bottom from the percolation of the liquid occurs countercurrently and percolation of the liquid occurs countercurrently and the decanting leg and co-current in the ascending leg, right? So this way it is reducing from one side, it is countercurrent, in another side it is in co-current. It is also very large lake, like 15 to 20 meter high, right? So it's a very tall equipment. So at the top of the tower, the basket are tipped into a hopper, which is provide a screw conveyor, and at the bottom to discharge the spent solid. So solid is collected at the bottom, right? So there are few advantages of Ballman extractor. There are few advantages of Ballman extractor. Number one, it can be integrated into continuous process, right? So a continuous process where it can give us the one side input, one side output, continuously product is formed in leaching. Second, it is very high efficiency. The solid liquid extraction is very high and it is very concentrated liquid is collected at the end. There are some disadvantages like cost of equipment is very high. Second, large equipment is used to maintain the optimal thermal profile in the it is so maintaining the thermal profile optimal throughout the equipment is very difficult because I have just mentioned in the early of the webinar. The temperature is very crucial role in the leaching. So if we have to maintain high temperature, it is very difficult in the Boltzmann extract. Right? The third thing, the hydraulic conductivity is so clear, is low, and it is impaired percolation. Sometimes channeling through leaf matrix also occur, which also have adverse effect on the efficiency. So these are the general disadvantage of the Boltzmann extractor. Clear? So I think most of the equipments are clear. Now moving to the material balance. When I say leaching of the solid, then there are two important things. One solid is soluble in the solvent. Now another solid is insoluble. So the insoluble component remain constant. Like consider this circle as a equipment. And solid to be leached is filled from the top, from the left side. And the solvent is also added. So we have in feed capital F mass, that is our feed of component A and C. The capital B is the insoluble solids. And from that, there is mass fraction of B available in the mixture. Now, what we are doing, we are leaching using solvent. So that solid is removed. That is, the leach solid is taken out. So two output. First is the leach solid that has very less amount of solute, or maybe say no amount of solute. And the solution that has very high amount of solute plus solvent. There won't be any insoluble solid in the solution, right? So the figure is a single stage operation. The capital B is the insoluble solvent which remain constant for the operation. The quantity is B is calculated as mass fraction of B into feed, that is F. So NF is the mass fraction of the feed. We can say is equal to E1 into N1 because it remains similar in the leach solid and feed solid. Both the insoluble solids that remain constant. Second, the material balance, the overall material balance. So how we can write the overall material balance? So there is a feed mixture, capital F. The RO is the leaching solvent. And there are two outputs. First is the extract E1 and the another is the R1, that is the solution. So E1 and R1. So F plus R0 is equal to E1 plus R1. Now, if we do the solute balance for the single stage, solute balance means our solute C. So that C compound has to be extracted from the solid. So feed into YF. YF is the mass fraction of solute available in the feed plus R0. What is R0? R0 is the solvent quantity. So R0 into X0. X0 is the mass fraction of solute in solvent. It might happen that X0 is equal to 0. It might happen. But in equation, we have to consider it. If sometimes we use recirculated solvent, then we have some 1% or less than 1% solute. In output, E1, that is the leach solid, into Y1 plus R1 into X1. So R1 is the solution and that has X1 amount of the solute. So this X1 is our target. If you are doing a leaching operation, please consider that X1 has to be maximized then and then the effective leaching is said to be performed. If your leach solution has lower amount of solute, then it is not useful operation. Right? So this is the solute balance. Now, when first what happens? The leached and solvent both get mixed. So M1, what is M1? M1 is the mixture. So mixture is mixed. Now that M1 is mixed and we have NM1, which is the mixture solvent, right? And that has the mass fraction of YM1. So this relation gives the relation for the mixture of the single stage leaching operation. And the quantity of solute leached from the single stage leaching is calculated from the above equation. So I guess the almost 4 o'clock is near, and most of the topic that I have considered is covered in this presentation. So is if there is any query, then I am happy to answer that as well. So yeah, Nitesh sir is here.
Yes, sir. Hello.
Ha.
Can you hear me?
Yes, sir.
Okay. So, no one receive in message. कोई क्वेश्चन आया नहीं है अभी. हेलो.
Good. Maybe everything is understand or something. Anything is not understandable.
ओके, सो 1-2 मिनट के लिए हम वेट करते हैं.
Yeah.
ओके. ओके, तो किसी ने अभी नहीं मैसेज किया है. कोई बात नहीं, ठीक है. तो we sincerely appreciate you for taking out time from your busy schedule to provide us with such valuable information for the leaching and everything of leaching information and the advantages of leaching and some leaching operation, material balance and component balance and overall material balance. The seminar earned a huge positive response. All thank you to your support. And on behalf of Parul University, thank you. Thank you very much, sir.
Thank you, sir.
Okay.
Thank you.
Okay, sir. Thank you.